Welcome back to Classic Car Restoration. Traditional methods of applying new finishes to metal parts have come down to either brush paint or spray paint in a can. Well, now with new advances in powder coat technology, we can powder coat at home. And to tell us more about that is Kevin Tates from painteducation.com.
Hey, Steve.
Kevin, fill us in.
All right. Powder coat in a home kit form is incredibly versatile and very cost effective. What powder coat is actually powder that's applied to the parts, to the bare metal parts, through a gun, through being sprayed on. And it's very versatile. It's actually plastic powder that actually melts onto the part. The thing about the powder coat is that it is resistant to most chemicals. It's a beautiful thing in that brake fluid won't eat it, power steering fluid won't eat it, thinners won't eat it. There's a couple of examples here of powder coat. These particular cabinets that we're on are powder coated. Powder coating has been used in industrial capacity for years, and it's very, very strong. This paint gun here, the gun body itself is powder coated, and that finish is not only beautiful, but it will be beautiful like that for the whole service life of that paint gun, in that it's not susceptible to solvent penetration like a paint would be. So as far as your use of application, it's incredibly versatile and very, very strong.
We're using a few parts off of our Thunderbird's engine for this process. Since the items will need to be baked in order to melt and set the powder coat, you need to choose items that can fit into a standard oven. And because of this, plastic pieces cannot be powder coated. Parts such as brackets, lids, and tanks are great for this process, and the new finishes will really dress up an engine. But before applying the powder coat, the parts need to be stripped down to the bare metal. Well, what do we do to prepare our parts for powder coating?
What we need to do is strip them down to bare metal, either with an abrasive or an abrasive blasting, clean them properly, and then just hang them and coat them.
Let's get started.
All right.
We're lucky to have a large blasting cabinet in our workshop. If you don't have one, you can strip the pieces using chemical paint stripper or sand by hand. The blasting cabinet makes quick work of stripping and cleaning parts. I simply place my arms into the blasting gloves and use the gun to shoot very small pieces of abrasive media at the item. The force of the media is enough to break down the dirt and paint. There are many different types of blasting media, from fine sand to glass beads to ground walnut shells. We use a polymer bead, which is great for removing paint but won't damage the surface. It's important to remove all of the paint and have an absolutely clean surface for the powder coat to adhere to.
Okay, so now we've got our parts out of the sandblaster. They're properly cleaned and they're mounted on our oven rack to save us a little bit of time on our way into the oven. And you can see the wire that we've got mounted on is stainless steel wire. The reason we use stainless steel wire, which comes with the kit, is because the stainless steel does not off-gas, or it won't release any chemicals into the air during the curing process for your powder coat, and it won't stain it.
The kit also comes with heat-proof fiberglass tape, which is used to tape off sections where you don't want the powder coating, such as bolt threads and machine surfaces. The powder coating process involves creating a static charge on the metal item to be powder coated.
Well, we've got a transmitter here, we've got a trigger assembly, and we've got a ground clamp, and we've got our gun. So basically, electrostatic application is positive charge and a negative charge, and it draws the powder to the part. So what we do is we ground each individual part, which is the negative charge, and we take our powder applicator, which is the positive charge, and we simply spray it on, and it attracts to it like a magnet.
And there's a compressor, of course, that drives the powder out of the applicator.
Yes, it's an air-applicated gun, so it's forced out with air pressure and then onto the part.
Because we're working with chemicals and fine powders, it's important to wear a charcoal respirator mask when powder coating. Kevin starts the powder coating process, spraying the fine powder towards the part. Like a magnet, the powder is drawn to the surface. Since this isn't paint, it doesn't run or drip, and powder is only drawn to the areas where it's needed, creating a nice, even coat. I carefully turn the rack so Kevin can reach the backside, but it's important not to shake the part and disturb the powder. Kevin continues to the other parts, moving the ground clamp as he goes. It's important to get all sides of the parts and the underneath areas. Once all of the parts are completely covered with powder, we can bake the finish on.
Now that we've got our parts coated, we've got our oven preheated to 450 degrees Fahrenheit already. We're going to transfer our oven rack into the oven and flow the parts out for 10 minutes. Once we've achieved flow out, we'll set our timer, and for another 15 minutes, we'll let the parts cure.
We've selected a matte black finish for our parts, which is correct for our car. If you wanted to, you could use a brighter colored powder or even a metallic or iridescent color. They are available. Wow, that is a tough, durable finish.
Yes, and that stuff's only been out of the oven for 15 minutes. So as soon as it's cool to touch, it's ready to put back into service.
So all we gotta do is bolt these things back under the hood. For complete instructions on powder coating, visit our website at DIYnetwork.com. When we come back, we're going to make our final underhood improvement. We're going to go from point-type ignition to electronic ignition. Don't go away. Welcome back to Classic Car Restoration. The ignition on our 1962 Thunderbird Sports Roadster project car is a mechanical breaker point type. Now, they were very reliable, but the only problem is they require regular maintenance in order to maintain good horsepower, clean emissions, and easy starting. The thing is, the points in these things tend to get pitted or corroded or just wear out, and if you don't change them annually, you can expect an awful lot of headaches, really. Well, we can do better now in the form of a direct bolt-in kit that replaces the breaker plate and points with solid-state magnetic trigger components. The manufacturer claims a doubling of the spark energy, which will give us better ignition, cleaner emissions, and more horsepower, along with a smoother idle and faster startup. It's a simple job. Let's get started. We begin by taking the distributor cap off, setting up out of the way. Pull the rotor off. I remove the breaker plate here, which houses the contact points and the pivot arm. I disconnect the coil wire at the negative side. The condenser also comes out. Okay, and it's out with the old. The superior alternative is the conversion kit, which basically has a magnetic trigger that goes by a sensor on the end of this module, which transfers magnetic signals into electronic signals and fires the plugs. There's no moving parts, it's solid state, and it provides twice the spark output as the stock point type system. So we'll have better fuel economy, more power, faster startups, and longer plug life. It's a win-win situation, and this bolts in a half an hour. Because our terminal ends won't go through the hole in the distributor body, I gently bend them using needle nose pliers, then I can insert them through the hole. I pull the wires until I can seat the rubber grommet in the hole, which will keep moisture out of the distributor. Then I can attach the ground wire and screw to the base of the new unit and secure the new module onto the plate. Next comes the magnetic trigger wheel. This fits down over the stock cam that used to run the points. Pops right in place. It's important to check that there is enough clearance between the magnetic trigger and the pickup. To do this, use the 30 thousandths thick gauge that comes with the kit and insert it between the parts. Ours is fine and the module can be tightened down. Then I go back and gently flatten out the wire terminals so I can attach them to the coil. I attach the black wire to the negative side of the coil and attach the red wire to the positive side of the coil. We have to remember to install the wire that comes from the ballast resistor and the ignition key on top of the wire that runs from the module for the electronic ignition. And that gets tightened down. The next step is to simply install the rotor back onto the distributor, but because we want to get full performance out of our new ignition, we're going to upgrade the cap, the rotor, and the wires and the plugs. So the old rotor actually goes into the dumpster, and we'll replace it with a brand new one. And that's done. Takes about a half an hour to upgrade from points to a breakerless solid-state ignition. It's a nice deal. Continuing our ignition upgrade, we'll change the original cap with a new replacement. Just put it right on like this. Now here's a trick that'll help to remove some of the confusion about changing these wires. This kind of looks like an octopus with all these wires sticking out of it, and it's easy to get these confused. If you do, the firing order on the motor will be wrong, and you won't be able to start it. So if you change them one at a time, using, basically find a reference point from that tab to that. We'll change this one here first. Hang on, we'll go clockwise. Do them one at a time. This way, you won't get lost. And then finally the coil wire is transferred. And the old distributor cap can go in the trash. Now we can see the thing that wears out distributor caps is electronic erosion between the rotor and these terminals. And if you can see any scratches or any kind of pitting or erosion, you know it's time to change the cap. We also decided to change out the spark plug wires, upgrading to high-quality silicone 7mm wires, which will ensure a good link between the distributor and the spark plugs. And as before, I used the one-at-a-time system of removing the old wires and installing the new ones. I pull each wire out one at a time and compare it with the new ones and select the right length wire. These are custom wire sets, so they won't need any cutting. They're ready to go. Then I simply install the wires and run them to the corresponding spark plug. The final link in our ignition upgrade is a fresh set of spark plugs. Now, just because they're new doesn't mean they're right. Sometimes rough handling can cause the gaps on these things to close up, so I always check them before we install them. In this case here, we'll see that we have 38 thousandths, which is right on the money. And because we're installing these spark plugs into aluminum cylinder heads, we want to be sure to use some anti-seize compound on the threads to prevent galling and sticking. Like so. When we come back, we'll finish up some of these underhood details and upgrade to halogen headlamps. Welcome back to Classic Car Restoration. The underhood area of our 62 Thunderbird project car is really shaping up. Now, we have changed some things here in the name of progress. For instance, we have aluminum cylinder heads, high-performance carburetor and intake manifold, and some chrome dress-up goodies. But because we respect this car's heritage and rarity as one of only 1,427 built, we have saved the original parts in case a future owner wants to restore the car back to original condition. Now, when it comes to the final details under the hood, we have a few things left to install. One of them is our fan shroud. The original that came on the car is kind of rusty, the paint's nasty, and it has some dents. Now, what we could have done with this is stripped it of the paint, sandblasted it, and then painted it again, and gotten a pretty decent result. In fact, I did this just yesterday in a couple of hours. But because of the dents and the bend, we've decided instead to replace it with a newer one that came off of probably somebody's parted out Thunderbird hardtop. Our new reconditioned fan shroud cost about $80 and has the original caution sticker on it. We found this item through the newsletter of the Vintage Thunderbird Club International. Car clubs are a great resource for parts, instructions, and information. We also found that we can buy authentic reproduction decals to detail our engine through the specialty Thunderbird catalogs. This particular kit includes everything from caution stickers to parts tags to jack instructions for the trunk. A final detail that we also picked up new, actually a new used part that's in much better condition, is the radiator yoke to hood seal. Now, the original one we had, again, had a lot of rust and the rubber was dry and cracking. So we bought this one that's been refurbished, and this one came out of Pennsylvania, so we'll be installing this on our car as well. This is a good time to talk about the radiator. Now, while our radiator has been in good shape since the beginning of our project, if you see any signs of leaking on yours or corrosion of the fins or tubes, be sure to take it out, bring it to a radiator shop, and have them flow test it. That will ensure that it has the ability to cool your engine properly. If there's any trouble, they can rot it out or re-core it for a nominal fee. The radiator shroud fits in place and simply gets bolted down to the radiator and the radiator support. This will protect the fan from any debris and help maintain the airflow. Next up is our radiator yoke to hood seal. You just basically bolt this right down here, and the bolts get tightened down. This hard rubber seal will prevent a lot of rattles and drafts in the engine compartment. The crowning underhood touch is a new windshield washer fluid bag. Now, back in the early 50s, Ford was a pioneer in going to these plastic bags versus the glass containers that we use for windshield washer fluid by the rest of the industry. But the trouble is, the stalker on our Thunderbird has a torn seal and it's a leaker, so we can't really clean this and reuse it. But the aftermarket comes to our rescue with fresh reproduction windshield washer cleaner bags. So all we got to do is plug this into the supply line, which goes up to the windshield squirters, and hang it onto our freshly powder coated bracket. And now we can move on to upgrading our incandescent headlamps to halogen. I start by removing the headlight bezel, which is held on with two small screws. Then I loosen the headlight screws, which fit into a locking clip. I simply loosen them and twist the bulb retainer out, and I unplug and remove the bulb. An important thing to remember on a 4-headlamp system like our Thunderbird has is that the low beams go to the outboard locations, the high beams go to the inboard locations. This makes life easier for drivers in the other lane at nighttime. The new bulb is positioned and then gets plugged in. The retainer plate goes back on and slips into the screw clips, and the screws get tightened down. And I continue with the inboard headlamp. This is the high beam bulb. I loosen the screws, remove the retainer plate, and unplug the old incandescent bulb. Halogen headlamps get their name because they're actually a bulb within a bulb. There's a miniature halogen bulb inside of the outer, which provides whiter, cleaner light and 50% more light than a standard incandescent bulb. The new high beam bulb is positioned and gets plugged in. The retainer plate goes back on and is tightened down, and the headlamp bezel goes back on. Those are some bright headlights. Well, we've done a lot of little things on our 62 Thunderbird Sports Roadster project car, but it's the little things that add up to big things and really enhance a car's value. Next time on Classic Car Restoration, we'll dig in on the dirty interior, clean it up, and install a brand new convertible top. So be sure to join us. And remember, if there's anything on today's show that you want to know more about, check us out on the web at DIYnetwork.com.